That's my CSE.
No, to go to the next one.
Oh,
What was everybody?
all right, I like it.
Figure out the stuff.
Yeah.
All right, yeah.
Pull up a chair here.
I like to sit here.
Good morning, welcome to August meeting for the Alabama chapter. Thank you for attending. Today we have a presentation by Mr. University of Alabama Safe State. I said Schimmel. That's correct. From the University of Alabama Safe State Program, he's the executive director. I'm sure he's going to have an explosive presentation today. S'mores at the end, so.
Oh, that was a quick introduction. Hi, everybody. A couple of you I know, so it's good to see you. So yeah, I am Chris. I still saying, although today's my 1 year anniversary, so I don't know if I can still say the new executive director, but it gets down to a lot of complications with the administration when I screw things up. I'm still going with the new executive director. Anyway, I came up from the University of South Florida, where so just 1 minute on me. I'm a PhD in chemical engineering, but I studied at a fire research center at the University of Edinburgh in Edinburgh, Scotland, right? Been classically kind of trained chemical engineer before that, except for the fact my entire career has been centered around fire and explosion hazards. Okay, I started with the Department of Energy in the mid-90s, the decommissioning of nuclear weapons facilities, and then tritium production, and then plutonium decommissioning. So I've done a lot of weird stuff early in my career with the unusual hazards. Then worked on into industrial consulting, had the chance to do this PhD program in Scotland. Actually, excuse me, found an employer to pay for it. So I jumped on that, went and did that. And since then have gotten in more into teaching and industrial training. Okay, so when I say I've worked all over the world, the only place I haven't worked is Australia and China, but I've done extensive fire projects everywhere else in all sorts of industries, mining, chemical production, and offshore, a lot of offshore work as well. So that's the background with which I'm giving you this talk from. I pull that into the safety world. Here, I actually have a slide. What my message is. My real message here is that we have methodology for doing investigation, right? When an incident happens, whether a fire, an explosion, or an amputation, or some sort of safety incident, we have methodologies that conduct these investigations, right? Fire has really gotten into it in a big way. And they have developed this NFPA 921 document, which is a guide for how to conduct investigations, which gives some good scientific methodology for use for all investigations. So my goal is to convince you with some really cool fire and explosion pictures that sound investigation using sound scientific techniques are really what you need to do, because you use these findings that come out of these incident reports to play, they play a significant role in improving safety, right? If you do things right. So this scientific, I like to call them scientific reconstructions in addition to just investigations. That's where we put some of the engineering work into it. And so the way I'm going to go through this is show you first off that fire is still a pretty big problem, still hurt a lot of people with fire. Talk about the scientific reconstruction. That's basically a couple of slides on showing you how the scientific method fits into investigation, at least for fires. And then look at some causation studies. And what I try to do is generalize the lessons learned, right? There's really, as I always say, fire is a simple thing, right? We have a triangle to explain it, right? And in effect, fire is hot, it's bad, water cools it down, it's good, right? It's a simple process. So if we learn a couple of simple things about the way materials behave and ignition behaves and what aggravates a fire situation, then we can apply those more universally. So we might have an incident at Randy's plant, right? Or at Randy's operation, and we investigate what happens there. And lo and behold, the lessons learned apply to Tom's area of the plant too, right? We can just make what I like to say, make the error bands on your findings wide enough to capture events that you didn't foresee coming, right? So that's my philosophy. Let's get to the message. Fire and explosion. 93%, I think it's a little higher now, according to the latest March report, of all large loss incidents in the chemical industry, petrochemical industry, come from fire or explosion. Okay, it is a massive event when it happens. And it really accounts for, in one way or another, through vapor cloud explosions, typical fires, or outright vessel or condensed phase explosions, the vast majority of large loss events in the world. I gave a talk to an OSHA conference in Tennessee about a month ago or so, and I went through and had an intern aggregate a whole bunch of data on fire injury statistics. It's a complicated mess, and there's no really fun way to show it, but I did want to pull the last 5 years together because this is pretty representative of the trend that we really are not seeing a reduction in incidents that result in injury and fatality from fire, right? They skip around, but when you do the math on these, the statistics, there is no statistical difference year over year on these losses, right? What you find too with reportable incidents with OSHA, the same sort of thing, right? Incidents kind of bounce around, right? A lot of people try to say they're tailing off, but when you really look at data, they're not tailing off that much. Now we're getting more industry and more complex industry, but we still have very real fire problem. And this kind of shows that it's representative across an awful lot of activities. From driving vehicles, storage, hot work, all of your usual suspects. But for the most part, when you look at this pie chart, fires can occur during all kinds of operations. That's one of the reasons I love it, right? As an engineer, I have seen fire, I've worked on fires from teeny tiny little control boards to, massive multiple mile explosions in coal mine, right? So you really get a lot of situations that these basic principles apply in. And again, if we can remember these principles for fire safety, I think, and figure out which ones apply to you in given situations, put you way ahead of the game in a safety perspective. Okay, so when we do an investigation, NFPA 921, which is really our driving document, but most forensic societies or whatever engineering group, when you talk about doing forensic analysis or failure analysis, it is, right, we're engineers or professional scientists of some sort, and we're supposed to use some sort of science and methodology to what we do. I kind of like this concept of the scientific method put out by 921. They go through, recognize a need for a fire. It's like, we have to do the investigation. Define the problem. It's basically, there was a fire. We want to know what started it. And then we get to sort of the good ones here of collecting data, analyzing data, developing hypotheses, and testing hypotheses. And it's going through these steps that give validity to the process because it allows you to iterate, right? Each one of these, as you come through and test your hypothesis to see if what you think happened and what you think was the causation of the incident actually fits with the data, the analysis you did, and that hypothesis works, okay? So this can be kind of a nebulous thing, but I do think if you adhere to this kind of methodology, at least, again, when we have the incident at Randy's section of the plant, and we do that investigation, we can turn around and hand it to anybody else, and they can see exactly how we arrived at the conclusions we did, right? We don't have things like, in my best judgment, or in my engineering judgment, or in my experience, this is what happened, right? We have, this happened, here's a reference, here's the performance on why it happened, and here's the test data to show it, okay? To represent that, got a text box. What do they call those? So the way I like to think about investigation, right, or evidence, dealing with evidence, when you have an incident, right, you walk out and there's all sorts of evidence. You got physical evidence, you got paper evidence, you got process data, you got witness statements. And in my mind, you look at these dots, those dots represent the totality of the evidence when you walk onto a scene for the first time and see what's up, right? Now, the problem with the physical evidence, you can put an awful lot of scenarios for the way an accident unfolded through most sets of physical evidence, right? You have a broken pump over here, a breached wire that looks like it's skinned something over here, might have been an ignition source and an explosion. You can come up with multiple ways that that might have happened, okay, with given those events. If you don't know something, if you don't have video, which we get a lot of today, but again, you need something to help you discern which scenario best fits the evidence. So the way I like to think about the scientific method, and all of these scenarios fit, we do things like conduct test programs. We see how materials behave. We recreate instances and figure out what will start a fire, how things will burn. And that helps us eliminate some scenarios. We figure out that some things can't happen, right? And then when we go that further step and analyze the data and do hypothesis testing, we can come up with data points that will show that one scenario is in fact the most likely, right? So this is just sort of a visual for me, I think, that helps, understand how you go through scenarios and eliminate them as you walk through. Okay, so again, the whole point of most of these investigations, right? We fought for years, especially as a consultant, which is what I do a lot of. Most people see outside consultants as blame assessors, right? We're brought in, Randy blew up his section of the plant. We want to fire Randy, right? So we bring in this consultant. Yeah, he goes, we want to add 10 more years to Randy's career. That's okay. But the idea is that these reports are often used punitively, and we've all fought in this business for this not to be used punitively, right? They are information gathering and process improvement reports, and it's really horrible when they use them. When you're sitting down with somebody and say, give me the top 3 reasons you're going to be fired after this interview, right? You do not get the same information as it is critical for the company to figure out how we put you in this position to where the decisions that were made resulted in this, right? So again, I think that to get good corrective actions and lessons learned, we have to approach investigation from that idea. And what we want to come up with are physical changes that we might be able to find to a process area, right? The configuration, the geometry has a huge effect on accidents or fires in particular. Come up with better, I began my, sorry about that. Unseated. Better work practices. So better ways of doing work, better writing proposals, someone like business, better writing of your work practices, your procedures, or even when you're putting together work packages and job hazard analysis, right? These things are now in on your checklist, right? If you're learning from your incidents or near misses. And then understanding new hazards. I've got an example here of a material that's used now in the food industry, and it was an unrecognized hazard as a fire hazard. I'm going to show you how we found that and how we're dealing with that now. So there, now you can see that. So here's my lesson learned. Tom wanted a lot of explosions, so in general, one of the key things to keep in mind about things that burn is that it depends on what state things are in that burn, right? Fuels can be solid, liquid, or gas. Flammable gases must mix with air to burn, right? But everything that burns, burns in the gas phase, right? Everything that burns, burns in the gas phase. So in order for a solid or a liquid to burn, it's got to transition to a gas phase to do that. So, and then mix with air. So there's multiple steps. You can imagine, as a fun-loving chemical engineer, we have a step and a couple steps there to melt the fuel. We have steps and we have to evaporate the fuel. And then we have to mix the fuel. We can write a system of 7 or 8 differential equations and have fun for weeks with this, right? But in reality, the thing you want to keep in mind is solid fuels are hard to ignite. Okay, they require exposure, outside heating, and ignition sources that are active through that entire process, okay? Liquid fuels have to evaporate, right? Flammable ones and combustible ones are a little bit different in their flash points, but basically flammable liquids will create a explosive atmosphere above them at atmospheric conditions. The fire, so flash point, fire point are used to evaluate that. But my real point in this is when you're dealing with any kind of fuel, gases are your biggest worry, right? Sparks are everywhere, static discharge is everywhere. If you have flammable gases that are not accounted for, you will have a problem at some point, okay? With liquid fuels, especially liquid flammable fuels, same thing applies, right? You have to keep control of the atmosphere above them with inerting or ventilation. As you go toward combustible, it's more forgiving. And then as you head towards solid fuels, with the exception of energetic solid fuels, you generally have time to deal with them and time to put them out once they catch fire, okay? So your hazard really kind of scales with the condition of the fuel. Gas fuels being the most hazardous, solid fuels giving you some time to do something about it. Now dust fuels are kind of interesting because they sort of live in this hybrid space. A dust fuel or a dust that's laying on the ground, I can light with a match, and if I can eventually get that to burn, it will lazily burn across the top of the table. I could have another set of dust where I accumulate them into a big pile. And because of the biological or chemical activity, it self-heats, right? It has the ability, like oily rags or hay that gets wet, to self-heat. So dust can burn, they can self-heat, or they can be suspended in air and become explosive very quickly. And when dust becomes suspended in air, if they're at the right size or if they're finely divided, they are as ignitable and as gas flames, or excuse me, as gas clouds, and they're almost 10 to 100 times thicker, which gives them 10 to 100 times more power radiant energy. Meaning, if I fire off in Randy's incident, right? If Randy had screwed up a gas exchanger, right, a natural gas handling unit, and I'm standing over here, it creates this fireball, I might lose my eyebrows or singe my hair and be like, Randy, what the hell? Right? If we had a dust handler or a bag house and the same incident happened, I'm receiving at least second and more than likely 3rd-degree burns, right? Because of that exposure time from the dust fuel. So dust fuels are particularly hazardous to workers and particularly invasive. They get everywhere. The other thing about dust, and this I talked about how easy it is to ignite. Here's common static ignition discharge energies. All but the smallest corona discharges, which will still ignite gases and vapors, will ignite powder. So any self-respecting electrostatic discharge has the ability to ignite both gases and vapors, which is why, again, these suspended dusts are such a safety hazard. This is a different fuel. This is one, people in the food industry here that work with spiral freezers, okay? So I do a lot of work for Nestle and some other food companies, Nestle being the biggest one, but when you bake prepared food, it comes out of the oven piping hot. They got to get it to a certain temperature, for sterilization process, and it's made, and then 10 minutes later they want it on a truck headed to a supermarket, right? So in order to get it frozen that quickly, they have these massive freezers with residence times of about 15 minutes where you enter. This was a hot pocket operation. So went in, came up, by the time the thing came out, went in piping hot, by the time it came out, killed somebody with this thing, right? Shatter if you drop it. But this belt material, this blue belt material, is a formaldehyde-based, excuse me, not formaldehyde-based, not to pull out off the top of my head, but it produces formaldehyde when it burns. It is a polymer that has surface tension that you can, the beauty of it is that you can set pastries on it at almost any temperature, like pastry, they can be sticky or whatever, right? I'm not the best cook, but you can set these pieces on it. They can transverse, a mile plus. There's no vibration. So they stay in their lines. So when they go to the packaging chamber, they're just in perfect line. Any other belt material, these things can shift around and it can be hard to have a continuous belt for the length that these run. So there's reasons they want this engineered material there, right? But when it came on the market, nobody bothered to tell people how it burned. So that might be fine. Let's see if this goes. Watch, this is a sample of this material. This took out a factory in Jonesboro, Arkansas, from a simple hot work incident where they saw the fire start, right? Workers are there, fire starts, fire extinguishers, everything. The geometry of that rack is like a Christmas tree. And this material, see if I can play that again. was burning for several minutes and the workers didn't realize it because they couldn't see the flames. That's in my laboratory, and you see those flames when you're right up on top of it, but they started it near the middle of that spiral and it eventually took out the entire factory. So materials, new materials that have fire tests on them that were very limited fire testing data on, you really want to understand before you put them in your facilities. Now it gets more fun. We have some explosions here. So I think one of the biggest releases that's relevant for a bunch of people are flammable vapor cloud releases, right? Of all of the explosions that I've dealt with that have really taken out property and people, it's vapor cloud explosions. And vapor clouds can, when they're released, if you release a vapor cloud in the middle of a football field, you end up with a nice flash fire or a big fireball, right? It can be decorative, right? The cheerleaders like it, everybody's. However, if you change the geometry of that situation just a little bit, things can change drastically, all right? So for the most part, you fill a volume like this with a mixture of like methane. This is methane and air. And we ignite, these were tests that were done in Norway to do some explosion classification. When we ignite on this end, this little chamber has these support beams in it, and uniformly, right, it's one big gas cloud, uniformly filled with methane and oxygen or air. And this is to look at the burning velocity. You're going to see an ignition on this side. You're actually going to see it's going to be pretty quick. So you'll see the propagation of the flame this way. And so flame speed propagation is like the speed of sound. For any given mixture, that flame speed should have a max value we can hit. So this runs. There we go. So watch the ignition on this side. Okay, so that's, if you had a release, that football field type release or release in one of your facilities into a parking lot, empty parking lot, something with no obstructions, this is the kind of behavior you would expect. Okay, very little pressure is generated, but it's going to roll through that flammable mixture and take out anything with it. But the overpressure, the blast wave, is going to be extremely limited. Okay. Now, same scenario. Well, that's where this plays. This is an old CSB video. I'm going to put this in. This was in Daytona Beach, Florida, where these guys were doing some hot work up above a methanol storage tank. You guys might have seen this video. A non-functioning, and the investigation determines non-functioning flame arrestor. And they're showering sparks down on top of this thing. And the idea here is it's gas monitoring. Now, I don't have the actual video from that one, but I do have one that I investigated out in Lemoore, California, a little bit over a year ago. It's a water tank. This is a sad story. Water tank coming out of a municipal well. They were decommissioning it. It still had water in it. The guy was going to put a big cut in it. Just the well's right there. It's just coming up. Just a big hole, a big water storage. You'll see it. Bring your kid to work day. The guy who is doing the cut, his son, is sitting about 100 yards from when this whole thing unfolds. This is from a security camera across the street. It's the water tank. Get another angle of it here. He's on a lift that you can see gets shot across this way. You can't see it at that angle. But that water, really there is on that boom is where the gun was, right? But that was water. They called me, I do work in that Central Valley of California for a lot of these municipalities. They called me, they're like, what the hell, right? So I said, go to the nearest spot from there, right, which was this junior college across the street. They took a little water bottle. They said, shake it up, put a gas meter on it. They were well above LAO. It was from the methane that they were pulling out of the municipal system. So this, as you can imagine, it's an interesting problem for a city to have, right? There were industrial plants nearby, and everybody's fire water tank was effectively a bomb in the distance. We had to get that cleared out and addressed, and help them install a air system that eradicated the methane from their water system. Common with the drought, they had this in a couple areas in that basin in Central California. But that was the first one. That was pretty brief. So anyway, how do you go then from a fireball? So that's kind of a lazy fireball, like I said, could do damage. But when you start confining things, those gas clouds become very dangerous, right? If it's confined in a vessel or a sump and blows up, it's got the confinement, it can build pressure and go, or a vapor release around obstructions, pipings and trees. Like in this room, imagine if we had propane, right? Heavier than air up to about here. As that propane flame front moves through here, these act like tank baffles. And the vapor starts tumbling and our mixing and our reaction starts taking place a whole lot quicker. Okay, so you can get very powerful explosions in confined areas. This is a test. Here, the only place we have fuel is right here. So this is a combination of confinement, obstruction, and then just empty space. The only place there's fuel is right here. But the point here, the result of confinement and obstructions in the flow path, watch the difference in these explosions. Okay, less fuel, right? Different geometry, bigger punch. That's a several PSI overpressure explosion that takes out walls, windows, and people's lungs. So, in conclusion, where I am with this, I would reiterate the point that I am a firm believer in sound scientific investigations and developing those into good work practices, right? I've seen too many investigations in my life that are either go into litigation, they do whatever. It's all well and good, it all makes money. But the reality is when we can tune these into process plants and take all of that vast information we've learned and create good categorical things for them to live by, that's the best use of these reports. And why I say that is been working about 30 years, I've been investigating stuff about 25, and there are so many commonalities in accidents, right? I am sure you guys see them too. There are so many commonalities in accidents. For fire, it's fuel state, right? Solid, liquid, or gas, really going to impact your hazard profile. Dust fuels, always be leery of dust fuels. They are potent and they cause much more severe injury than gas flames do. Engineered materials, as you get a new material, understand it. Don't always rely on the product cut sheet on what fire performance is. Get it tested. That material, that blue belt material, had a very acceptable flame spread rating. So engineers, when they looked at it, they're like, yeah, what the heck, this looks good. What they didn't tell you on that flame test or the fire test was how easy it is to ignite and how hard those flames are to see. Hot work, any hot work is dangerous, but never, ever, ever cut into an unknown atmosphere. The response from the guy's supervisor at that water tank was, it's a water tank. It was an unknown atmosphere. His idea was, it's a water tank. What could be on the other side? It's like, that's the question you need to answer, right? What could be on the other side? And then watch congestion in your flammable vapor areas, right? Congestion in confined spaces mixed with flammable vapors are deadly, very deadly explosion risk. Anyway, that's what I got. I think that gives you lunch in time too. If you have any questions, I'd be happy to chat. Yes.
Factory in Arkansas, how do they fix that for the flames you cannot see in that particular equipment?
And with that redone, we went with redesigned the belt, but with a different type of belt. Instead of that material, we switched to nylon, which is a little bit more of an engineering challenge to get in. They had to segment it, but it still was a doable thing. Now I've seen this material even here in Alabama. I've worked a couple of fires where this material is.
The engineers who designed that didn't think of it that you can see the fire and
They didn't know. They actually had gone to the manufacturer of that belt, and the fire test data that they supplied, they gave the heat release rate, kind of the standard stuff you give, the flame spread rating, which is fine, but they did not talk about. There were two things. One is, since it's a spiral, it drips and it was lighting all the other layers on fire. And then you get the chimney effect, like a Christmas tree. But the big thing was that they never showed how easy that was to ignite. I'd done experiments. I had a belt laid out flat in my lap. I took a big lighter in like 2 seconds and then just walked away just to see it. Sure enough, the flame stabilized after about 2 minutes on that, just from that tiny little heat exposure.
Is that that same company that designed it, or did they hire a third party to build that particular?
And they just made, they didn't design the stuff. They just made the belts.
Did anybody die?
No, it's fortunate they were. The firefighters who responded would say 3 of them almost did, because unfortunately, the way the building was, these freezers are tight, right? And it was put in and the freezer itself over pressurized and popped, and the building kind of popped from that. So it was more of a frightening as hell experience for the firefighters. I don't think it was a near death experience. They see it differently. I don't blame them. They were there. Yes.
Doctor, one thing we had at the mine conference last year, we had Amerex in, and we were talking about the new hazards in the mining industry with all these new batteries and all that. If the equipment goes underground and catches on fire, there's no putting it out.
Right.
And so, people are doing research, they're getting, people buying electrical vehicles, and people that have that have money, so they park it in a beautiful garage at home, in a $500,000 home, if it catches on fire.
The electric batteries are, and unfortunately, in the fire world right now, most of the response to it is putting it out, increasing sprinkler density, this kind of thing. I was at my first meeting yesterday, it's a timely question, on a new DOE research grant that Alabama Institute of Work that would look at actually trying to attack that within the battery itself, trying to take the things that we use for standard, like the compartmentalization of this room, right? You've got fire doors, these are not firewalls, but this area is compartmentalized from the building, trying to take those concepts into the cellular structure of the battery. It's kind of I wouldn't call it pie in the sky project, but it's definitely on the theoretical end of this, but that's what's gonna have to happen with batteries, right? It can't propagate cell to cell, because once you do that, you go to thermal runaway, you can't stop it. But if you can stop that within a cell, you might have a shot, because and I was just in a mine last week, right? Everything's electric. So if they could go to batteries versus those long ass cables, they're gonna try and do it as quickly as they can. So batteries are a big, big problem, and probably decades till be resolved. So. Anything else? Great, well, thank you guys very much. I'll stick around.
Show our appreciation. We'd like to give you the ASSP coveted mug. This one doesn't explode and fall apart like the one Tuesday. Sorry about that, but you can enjoy it forever. Enjoy lunch. We have to take these home at, that are on.
Easier to maintain a four-wheeler or side by side.
Thanks with you.
Now that everybody's got food, mouth, let's go ahead and do the pledge. If you join me in the pledge, please.
Allegiance to the flag of the United States of America, to the republic which stands one nation under God, indivisible, with liberty and justice for all.
We do it perfect.
Dear Lord, we thank you for the opportunity for us to gather together. We thank you for the food. We thank you for the speech today, the talk. I just ask you to take whatever we've learned today, be able to apply. Bless our companies, bless our employees. Just help us to do the purpose and mission that you have for us. In all things, we're grateful and thankful. Amen.
Is there any numbers here for the first time?
Yes, as long as I've been in this stuff, I know a lot. I buy cattle with All Safe Industries. First time I've got to be at the Birmingham meeting in person. So it's been a distributor in safety business for 40 years this past May.
Welcome, thanks. Any announcements? Anybody? Another story? Talk about?
Yeah, I was working on my Ocean 300 the other day and thought about something that happened earlier in the year that might make that I think makes a good story. So we are an engineering firm that helps our customers to choose materials and to test them. We have a shop that will cut the parts up to the right size in order to be consistent, to see if the test, what changes along with it. You know what size it is. So the shop is very precise. They have the CNC machine. So we have an operator who's setting up a CNC machine, everything together and ready to go, and then realized that he needed to change the platform where the part was attached. And he reaches in without repositioning the cutting tool. So he cuts his arm, take a little bit there. It could have been worse. Yeah, it could have been worse, but we only needed stitches in order to close it up about 15 stitches. So we got, everybody came and helped him because he's bleeding, he's taken care of. We write it up, we have a meeting with the guys, we say, this is what we're going to do to change. It's a procedural thing, and we kind of followed up from there. A couple of months later, having a safety meeting with the guys, and we had some first aid training and some stop the bleed training and those kind of things, and was talking about how we are, making sure that we're prepared with the right equipment out there for first aid. And just by the way, when we had a and then they got telling me how they were so prepared. So I assume they go to our first aid kit, our EMT bag, and pull out what they need. Where did they get the stuff? Well, I had it in my pocket, my first aid kit for when I go home. I had over here a wrap that I used because I'm often going home and we're out in the woods and I might run into a friend, I need to help them. So basically they didn't use our first aid kit. They used the stuff that they had, that they kept in their toolbox or kept in their pocket. So why? What's going on? In other words, they didn't feel that it was ready. That was enough stuff in there, that they had the right kind of equipment. So went back, talking to them, helped us to purchase stop the bleed kits, actually purchase some tourniquets and those kinds of things. Now they feel more comfortable. Now they feel we've actually got stuff at work that we can use. And thankfully I had it in my pocket before, but now, the company is supplying what we need to do. So what is the lesson there? One of it is just listening to the people, talk to them when you're planning. It's not just about, what comes after. We had a meeting beforehand and said, hey guys, what do you think about first aid kits? It was that I would just throw those away and start over. So I learned a good bit from working with those guys and make sure they're prepared for that kind of thing. Great.
Yeah, that's the Friday before the governor's conference. Governor's conference is coming up, August 26th through 28th. It's already full, but, yesterday's email or 2 days ago email said that there's still, space available to go to 2 courses that they haven't before the conference. One is going to be on warehouse safety, the other one's on record keeping. So that's still available if you want to head down to the beach for a couple. ABC, UA Safe State, the Alabama chapter of ASSP is going to have a Silica Hazards and Solutions on October 4th, most likely at the ABC location in downtown Homewood. It will be there. So they had too many, they're talking about going to their auditorium, which is a possibility if a lot of people sign up. But that's coming up October 4th. Was it 26th of October? Will be the ROC meeting. 28th of October.
24.
So the fall ROC meeting for Region 4 will be the 24th of October over at the University of Alabama Bryant Conference Center. The Alabama chapter is gonna be putting that on, just so you know, maybe we're this week as well, so. Let's see. Already talked about the silica coming up, that's on October 4th, that will not be a meeting. October 18th, we really don't have a scheduled, meeting presentation yet, we're still working on that, but we're pretty much covered till the rest of the year. Jordan Casey and Steve Sawyer are gonna do a rigging presentation in September. And in November, we're doing earthquake issues and corrective actions. And then in December, we're gonna do a regulatory update. OSHA, ADM, and MSHA will be doing basically a roundtable regulatory update, question and answer event. So that should be that was pretty popular for folks. Will be popular. So training opportunities out there from the development safety, OSHA training group. There's a coming up in September. I just put a couple down. The OSHA 500 training support for construction will be the Brian conference. They also do a lot of vertical training. They have a lot of post-gated training, vertical training. OSHA 3095 with their 15. Deep South Center for Application Safety now has a class this week, and then they really don't have anything until November, and that's going to be running for a bit. And that's all I have. We'll see you September 5th. Presentation by Brashville Memorial, Steve Sawyer, and Casey Jordan.
I was wondering if anybody had done anything with Safe and Sound Week.
You do that week. Don't you do anything for Safe and Sound Week?
Not really this year. We don't have Jason anymore. So. we don't have anything.
Yeah, we didn't either. I was just wondering. See it on the calendar.
We were in the managers meeting, you know, and so.
So I wasn't able to go to the ASSP National Conference out in Denver this year, so I missed that event. I was lucky enough to go down to Orlando, Florida, for the Region 4 conference. But Charlie went out to conference in Denver. Charlie, you want to say anything about the conference? How well it was and interesting stuff?
It was fun. I mean, did anyone ever actually been to the national conference? Yeah. Okay, everyone does, it's overwhelmed. Just a couple of things. Starting in September, anyone can join any common interest group. They've waived the fee, and also this sounds weird, me saying this as the white male, basically buys and wise, but told me I could join, so that's new. I did my own little research. And I found that basically the reason they're basically saying, hey, you can join any kind of common interest group, or what's it, practice specialties, what was the other one, practice specialties? Yeah, it's basically they're going up over the next week. That was fun. The expo, two things I saw that really stand out, the two things that's being sold, the new style hard hats. Also saw those a lot in Tennessee, and what I mean by that is a type 2. That looks like the hiking helmet that has like the chin strap. And I mean by everyone is selling it, it's the hot new PPE, and it was everywhere. I talked to a couple of vendors. I'm trying to get some samples. So if I'm able to pull that off, I can obviously bring it in for people. And the other one with the hard hats for every other booth. AI was also every other booth. There was a lot of sessions that shoehorned. That's the reason I texted you and asked you. There was a lot of, I was in 2 or 3 sessions that somehow shoehorned AI into it as well. I don't know anything about it. I know as good as what you put into it, but it seems like everyone had the new special AI. They could do all kinds of stuff as far as real-time risk analysis for people in confined space, to cameras in a warehouse that can watch your workers and study their movements and give you their ergonomic issues. So I guess it's here. It was a little bit last year. This year was everywhere. Trying to think if there's any bolts. The leadership conference as well. That was also overwhelming. I feel like I was the only person in the room and did not know someone until I randomly ran into Danny Smith in one of the sessions. I was able to meet ASS people from all over the country, from the Northeast regions, like DC, New York, all the way to Honolulu and Alaska. One thing I learned is West Vincent, I guess the ASSP email system is basically hot garbage and no one likes it. I've never had to deal with it. Everyone is.
Find that out.
Yeah. But basically everyone said it's not user friendly and a lot of chapters, I guess, is having major issues of not everyone getting emails through the system. So. And the other stuff is like statistics and stuff I can talk comes to.
Charlie, enjoy your lunch, have a safe trip home. One thing.
Congratulations to the Alabama chapter, to the leadership and to the membership for being awarded gold status for chapter performance. That is high praise at this point in time in terms of accomplishment. So that was something the chapter did get. So congratulations to everyone for their efforts.
Mississippi and Alabama. He's the, what's that you want to call yourself?
Titles area director.
Know-it-all, boss, whatever you want to call him. He's, our boss for the next 3 years.
I wouldn't say boss, but
Let's tell him based on Nationals input and so forth. And yes, yes.
You said you felt like you were the only one that went out there. Several years ago, a group of about 10 of us from this chapter went out to Denver for that, and it was so much fun because everyone, I mean, we broke up, but you know, everyone was there at night. We went out to dinner and got to meet a lot of people, and it was so we need to really get that back where if there's a big national, you go to it, you know, and we planned it, but there were 10 of us that went.
If you,
Photos of it. If photos put on a website.
I'm very lucky where I get to go to different conferences. My job sends me. I've been to this number 3, and I still got one more this year. Is wearing me out. If you have a chance to go to a conference, especially if your company will pay for it, I highly recommend the national conference. Especially if you're, I consider myself a younger safety person. If you just graduated from ASU, you will meet so many people just by being there. Like I said, the leadership conference, like I said, they talk about the social events. Advise had like a social event afterwards. You know, I went to a couple other places and met people. I'm lucky to I have a group of friends I've worked with over the years. We meet up there. It's kind of fun. But yeah, the leadership conference was just kind of like, yeah, I'm the new guy here. But yeah, I highly recommend it. Next year is in Orlando. I ran into the Central Florida president. Take just a grain of salt because he seemed kind of high strung anyway. He is actually worried about the area and hotels. So immediately, if you are planning on going, and as soon as ASSP lists that giant list of hotels, I would possibly jump on it because the ASSP conference coincides with Universal opening up their new theme parks. So it's all an international drive. So if anyone's been to Orlando and know how the drive is.
Disney's got a couple.
What do you know if you do see is going to be in the spec room?
Another conference that's here in Birmingham at Rock Bridge. So if the company can afford to put you in there, what a great place to bring your wife and let her sit in the spa and all that kind of stuff. And it's the last of October, the Southeast MSHA Mine Safety Conference. Okay, and after COVID, we were almost 600 people, but now we're back up to about 500 after COVID. But when people say, "What's the mine conference?" Safety is safety. You can put OSHA, you can put MSHA, the subjects are absolutely the same. And so we really encourage, I have a lot of friends from like Nucor Steel and people like that, that come and they have nothing to do with mining. But they learn, and it's in Birmingham, Alabama, which for those who come from that hotel and all that, it's convenient to go. And there's a great pre-con. I'm just advertising the pre-conference, it's 8 hour for maintenance and contractors. We always have a great 8 hour session with them. So, we'd love to have you there. And go down to the governor's conference on Tuesday afternoon. Normally when everyone gets tired and doesn't go to the very last session, I'm teaching one of the very last session. That's fine.
Looking so nice there.
Give you one of the last sessions on the last day, huh? On Tuesday.
You can do it out by the pool.
That's what you're saying. You make it more.
Are you at 8 o'clock that morning, you want to switch?
Yeah, it was 8 in the morning, everybody just had breakfast, so they'll be sleeping.
The Tuscaloosa, West Alabama ASSP section will have a meeting on Friday, September 13th. The topic is not quite decided just yet, although I think maybe the leader in the clubhouse now is doing a critical review of the proposed OSHA heat standard. So that could end up being our topic, for sure. But just let you know, mark the calendars, September 13th, Tuscaloosa League Gateway Center here in Alberta.
It's on Friday 13th, yes, my calendar. See you September 20th, or the governor's conference. So hungry. Other than Vince and I